Hello friends, now we will start the new chapter sequences and series. In this video, I will explain all short examples and all examples from exercise 2.1. Now let us start. But before that, what we are learning in this chapter? AP and GP, arithmetic progression and geometric progression, sum of n terms of a GP, sum of infinite terms of a GP, and HP and AGP. AGP means arithmetico-geometric progression. Next, arithmetic mean, geometric mean, harmonic mean. Okay, now let us start. Let's recall sequence. A set of numbers where the numbers are arranged in a definite order, like the natural numbers, is called a sequence. Examples: natural numbers, even integers between 10 and 100, squares of integers. In general, a sequence is written as T1, T2, T3, T4, and up to Tn, where T1 is first term, T4 is a fourth term, and Tn is nth term. Finite sequence. A sequence containing finite number of terms is called a finite sequence. That is, we can count the terms of that sequence. Therefore, it is called finite sequence. It is written as T1, T2, T3 up to Tn for some positive integer n. Next, infinite sequence. A sequence is said to be infinite if it is not a finite sequence. It is written as T1, T2, T3 up to infinity for Tn where n is greater than or equal to 1. Sequences that follow specific pattern are called progressions. In the previous class, we have studied arithmetic progression AP. Now, see this here, arithmetic progression AP. In a sequence, if the difference between any term and its preceding term, that is a Tn plus 1 minus Tn, is a constant, then the sequence is called an arithmetic progression, that is AP. Okay, it is called AP. Next, consider the following sequences: 2, 5, 8, 11, 14. Next sequence: 4, 10, 16, 22, 28, and dash dash. Okay. Next, 4, 16, 64, 256. Next, 1 by 5, 1 upon 25, 1 upon 125, and the dash dash. Next sequence, minus 3, 2, 7, 12, 17. Okay. These sequences 1 to 5. The sequence 1, 2, and 5 are AP. Okay. That is the difference between two consecutive terms is constant. But the terms in the sequence 3 and 4, 3 and 4 are not in AP. 3 and 4 are not in AP as the difference between their consecutive terms is not constant. If T1, T2, T3 up to Tn are in AP, then the difference, that is the Tn plus 1 minus Tn, is equals to D for all n. Okay, see this here. Hence, this sequence can also be written as A plus D, A plus 2D. Okay, its nth term is Tn is equals to A plus in bracket n minus 1 bracket complete into D, where T1 is equals to A. Okay, and sum of n terms, that is a S suffix n, is equals to T1 plus T2 plus T3 up to last term Tn, and that's equals to n upon 2 in bracket 2A plus n minus 1 into D. This is the sum of AP. Okay, and the nth term of AP is a Tn is equals to A plus n minus 1 bracket complete into D. This you all learn in 10th standard. If T1, T2, T3 up to Tn are in AP, then T1 plus K, T2 plus K, T3 plus K up to dash dash Tn plus K are also in AP. If we add the same element in each term, then the new sequence is also in AP. Okay. Next, KT1, KT2, KT3 dash dash up to KTN are also in AP, where K is not equals to 0. Now let's learn geometric progression. A sequence T1, T2, T3 up to Tn is GP, that is a geometric progression, if common ratio Tn plus 1 upon Tn is equals to R is constant for all n. Hence, a geometric progression can also be written as AR square AR cube dash dash, where A is a first term and R is common ratio. Examples. See, this is the first example. 2, 4, 8, 16. Here the first term is A, that is A is equals to 2. Now what is the common ratio? That is a 4 upon 2. Then you will get R is equals to 2. 8 upon 4, you will get again R is equals to 2. 16 upon 8, R is equals to 2. Okay. And here the first term A is 2 and the common ratio R is equals to 2. For the next sequence, A is equals to 1 and the second term is 1 by 3. 1 by 3 upon 1, then you will get R is equals to 1 by 3. 1 upon 9 upon 1 upon 3, then you will get here 1 by 3, and hence in this sequence the first term A is equals to 1 and the common ratio is 1 by 3. Now for the next 1 minus 1, 1 minus 1, 1 minus 1. This sequence is also in geometric progression. Here again the first term A is equals to 1 and the common ratio, that is a minus 1 upon 1, then you will get here R is equals to minus 1. Next, the general term or the nth term of a GP. Okay, for GP, here T1 is equals to A, T2 is equals to AR, T3 is equals to AR square, T4 is equals to AR raised to 3. Okay, if A and R are the first term and the common ratio of GP respectively, then its nth term is given by Tn is equals to A into R raised to n minus 1. Okay, now see this here, the example 3 minus 6, 12, 24 and dash dash. And here find n term of GP. Okay, it's very easy. The first term A is equals to 3. What about the common ratio? That is a minus 6 upon 3. Then you will get that ratio is R is equals to minus 2. Or 12 upon minus 6. Again you will get R is equals to minus 2. What is the formula for Tn? That is a Tn is equals to A into R raised to n minus 1. Substitute the value of A. What is A? A is a 3. R is minus 2. That is a 3 into in bracket minus 2 bracket raised to n minus 1. This is the Tn. Okay. That is Tn is equals to 3 in bracket minus 2 raised to n minus 1. Okay. Now next, second, 5, 1, 1 upon 5, 1 upon 25. And here again, the first term A is equals to 5. What about the R? 1 upon 5. The common ratio is 1 upon 5. Therefore, Tn is equals to a into r raised to n minus 1. First term is 5 into 1 by 5 bracket raised to 1 upon 5. Now here, if we take this term, that is a 5 to the denominator, then you will get here 1 upon 5 into 1 upon 5 bracket raised to 1 into 1 upon 5 bracket raised to n minus 1. And after their product, then you will get here 1 upon 5 bracket raised to n minus 2. हा जर 5 तुम्ही डिनोमिनेटरला आणला तर त्याची पॉवर किती होणार, तर -1 होणार. ओके, अँड ओव्हरऑल दॅट इज 1 अपॉन 5 होल ब्रॅकेट रेस टू -1 and into 1 upon 5 whole bracket is to n minus 1, and then finally you will get here 1 upon 5 bracket is to n minus 2. Okay, now the properties of geometric progression. If t1, t2, t3 up to tn are in gp, then 1 upon t1, 1 upon t2, 1 upon t3 up to 1 upon tn are also in gp. Means what? The reciprocal of the terms are also in gp. Next, if k is not equals to 0, then if we multiplied k to every term, then k into t1, k into t2, k into t3 up to k into tn are also in gp. Okay. Next, t1 raised to n, t2 raised to n, t3 raised to n are also in gp. Now, solve examples. The first example, verify whether 1 minus 3 by 2, 9 by 4, minus 27 upon 4 is a GP. If it is GP, find its ninth term. Now here T1 is equals to 1, T2 is equals to minus 3 by 2, T3 is equals to 9 by 4. The ratio, that is a T2 upon T1, means what? Minus 3 by 2 upon 1. Then you will get here minus 3 by 2. Okay. Next, T3 upon T2, that is a 9 by 4 upon minus 3 by 2. After multiplied and reciprocal, you will get here minus 2 by 3. And next simplification, you will get here minus 3 by 2. Okay, the ratio is constant. And here, the ratio of any two consecutive terms is a constant. Hence, the given sequence is a GP. Now next, T9 is equals to A into R raised to 9 minus 1. Okay, now substitute the value of A, that is A is 1, and the value of R. R is a minus 3 by 2 whole bracket raised to 8, and then therefore you will get the ninth term is equals to 1 into in bracket minus 3 by 2 bracket raised to 8. Okay, now next example number 2, which term of the sequence root 3, 3, 3 root 3 is 243. Okay, here A is equals to root 3, R is equals to root 3. That is the first term, A is equals to root 3. What about the second term? 3 upon root 3. Then you will get here R is equals to 3 means what? Root 3 into root 3. That upon 3. Then root 3 root 3 get cancelled. You will get here R is equals to root 3. Or this 3 root 3 upon 3. That 3 will get cancelled. You will get R is equals to root 3. Here we have given that Tn is equals to 243. Now we know the formula. Tn is equals to A into R raised to n minus 1. That A into R raised to n minus 1 is equals to 243. Okay, now see this here, the ratio. Okay, R is equals to root 3. Substitute the value of A. A is a root 3. R is a root 3. Whole bracket raised to n minus 1 is equals to 243. But what about the 243? 243 is the fifth power of 3. Therefore, 3 raised to 5 is equals to root 3 into root 3 whole bracket raised to n minus 1. That is this root 3 raised to 1 into root 3 raised to n minus 1 plus 1 minus 1 get cancelled, and overall here you will get root 3 bracket raised to n, and that is nothing but 3 raised to n by 2 is equals to 3 raised to 5. Now equate their powers because the base are equal. Therefore, n by 2 is equals to 5, and hence n is equals to 10. Therefore, 243 is the 10th term of GP, and this is the answer. Now next, example number 3. For a GP, if A is equals to 3 and T7 is equals to 192, find R and T11. Now see this here. The first term is 3. T7. Now here the formula T7 is equals to A into R raised to 7 minus 1. Means what? R raised to 6. And that is equals to 192. Now next, again substitute. The value of A is 3 into R raised to, again 6 is equals to 192. That is R raised to 6 is equals to 192 upon 3. After division, you will get R raised to 6 is equals to 64. Now here R raised to 6 is equals to 64. But what about the 64? 64 is the sixth power of 2. Therefore, after equating, you will get here the value of R is equals to 2. And hence, next T11 is equals to A into R raised to 11 minus 1. Means what? R raised to 10. Substitute the value of A, that is a 3 into 2 raised to 10. And after simplification, you will get here 3072. Okay, and we have completed this activity. Now next, example number 4. In a GP, if the third term is 1 upon 5 and the sixth term is 1 upon 6 times 5, find its nth term. Okay, here T3 is equals to 1 upon 5. T6 is equals to 1 upon 625. Now T3 is equals to A into R square is equals to 1 upon 5. This is the first expression. T6 is equals to A into R raised to 5, and that is equals to 1 upon 625. Okay, dividing second by first, then you will get here A R raised to 5 upon A R square is equals to 1 upon 625, this whole divided by 1 upon 5. A get cancelled, R raised to 5 upon R square, you will get here R raised to 3. And after simplification of this, that is 1 upon 625 into 5 upon 1, then you will get here 1 upon 125. 125 is the cube of 5. Therefore, R cube is equals to 1 upon 5 raised to 3. Take cube root on both sides, then you will get here R is equals to 1 upon 5. Okay. Substituting in equation number 2, then we get here that is A into 1 upon 5 bracket raised to 2 is equals to 1 upon 5. After simplification, 1 upon 5 means what? 1 upon 25. A into 1 upon 25 means what? A upon 25 is equals to 1 upon 5, and hence you will get here A is equals to 5. Okay, that is A is equals to 25 into 1 upon 5, that is the 25 upon 5. A is equals to 5. Okay. Now next, Tn is equals to A into R raised to n minus 1. Substitute the value of A and R, that is the 5 in bracket 1 upon 5 raised to n minus 1. This is the nth term. Okay, that is the 5 into. If we take this 5 to the numerator, then the sign of this indice will change. याचे साइन काय होतील तर चेंज होतील. This plus n will become minus n, plus 1 will become minus n, minus 1 will become plus 1. Okay, therefore 5 into 5 raised to 1 minus n, and that is equals to, या 5 ची power किती तर 1 आहे, that is 1 into 5 raised to 1 minus n. Then you will get here 5 raised to 2 minus n, and this is the nth term. Okay. Next, example number 5. If for a sequence Tn is equals to 5 raised to n minus 2 upon 4 raised to n minus 3, show that the sequence is a GP. Find its first term and the common ratio. Now the solution, here Tn is equals to 5 raised to n minus 2 upon 4 raised to n minus 3. Next, Tn plus 1. Replace here n by n plus 1. Then you will get here n plus 1 minus 2 means what? 5 raised to n minus 1. Again here replace this n by n plus 1. N plus 1 minus 3 means what? 4 is to n minus 2. This is Tn plus 1. Next, their ratio Tn plus 1 upon Tn. That is a 5 is to n minus 1 upon 4 is to n minus 2. And this whole divided by Tn. Tn means what? 5 is to n minus 2 upon 4 is to n minus 3. Then next simplification, multiply it and take the reciprocal of this. Okay, then you will get here 4 is to n minus 3 upon 5 is to n minus 2. And see this here, the next simplification. 5 is to n minus 1 minus 5 is to n minus 2 means what? Minus in bracket n minus 2. What about the 4 raised to n minus 2? Take this term to the denominator. Then you will get here 4 is to n minus 2 minus n in bracket n minus 3. And then after simplification, if we open the bracket, the sign will change. That is a minus n plus 2. Next minus n plus 3. And overall, you will get here 5 by 4 for every n belongs to set of natural number. Okay. The given sequence is a GP with R is equals to 5 by 4 and it's a first term. That is a T1 is equals to 16 upon 5. Okay. Now next, note that three numbers in a GP can be conveniently assumed as A upon R, A, AR. When there are the three numbers in GP, then we can assume what type of the numbers will be that. That is, first number will be A upon R, second number is A, and third number is AR. Next, assume four numbers in a GP as A upon R cube, A upon R, AR, AR raised to 3. Here the ratio is R square. Okay. Assume five numbers in GP as A upon R square, A upon R, A, AR, AR square. Okay. प्रॉब्लेम सॉल्व करण्यासाठी हे सर्व तुम्हाला लागणार आहेत. ओके. नेक्स्ट एक्झाम्पल नंबर 6. Find three numbers in GP such that their sum is 42 and their product is 1728. Now solution. Let the three numbers in GP be A upon R, A, AR. A fixed formula असणार आहे. As their product is 1728 and it can be written as A upon R into A into AR is equals to 1728. Here RR get cancelled. A into A into A. Then you will get here A cube is equals to 1728 and this is nothing but the cube of 12. Therefore, A cube is equals to 12 cube. It means that A is equals to 12. According to first condition, their sum is 42. Means what? A upon R plus A plus AR is equals to 42. The next step, substitute the value of A, that is a 12 upon R, 12, 12R is equals to 42. Okay. Now see this here. That is a 12 upon R. Shift this 12 to the right hand side. 42 minus 12. Then you will get here 30. That is a 12 upon R plus 12R is equals to 30. Multiply this expression by R. Then you will get here 12. 12 upon R into R means what? RR get cancelled. And finally you will get here 12. Next 12R into R. You will get here 12R square. 30 into R, 30R. And this is the quadratic equation. Therefore, 12R square minus 30R plus 12 is equals to 0. Now, divide the whole expression by 6. Then you will get quadratic equation 2R square minus 5R plus 2 is equals to 0. Now, the factors are, what are the factors? That is a minus 4R minus R. And after simplification, you will get here in the first bracket 2R minus 1. And in second bracket, R minus 2 bracket complete, that's equals to 0. And hence the value of R, that is a 2R is equals to 1, R is equals to 2, hence R is equals to 1 upon 2. and r is equals to 2. Okay, these are the values of r. Now next, we want to find out three numbers which are in GP, and that numbers be a upon r, a r. Now substitute the value of a and r. If a is equals to 12 and r is equals to 1 upon 2, then the required numbers, that is a r is a 12, 12 upon 1 upon 2. Then after simplification, you will get here 24, 12 and 6. Next, if a is equals to 12 and r is equals to 2, then the required numbers are 6, 12 and 24 after substituting the values of a and r. Okay. Therefore, the required numbers are 24, 12, 6 or 6, 12, 24 are three required numbers in GP. Okay. Now next, example number 7. Find four numbers in GP such that their product is 64 and sum of second and third term is 6. Now solution. Let the four numbers be a upon r cube, a upon r, ar raised to 3. Okay, here the common ratio is r square. According to the first condition, their product, that is a upon r cube into a upon r into ar cube is equals to 64. And here that is a into a into a into a, that is a raised to 4, r cube into r, that is r raised to 4, and here r into r cube, r raised to 4, r raised to 4, r raised to 4 get cancelled. Then you will get here a raised to 4 is equals to 64. Okay, but what about the 64? 64 can be written as 2 raised to 6, and taking the fourth root, then you will get here a is equals to 2 raised to 6 and whole bracket is to 1 by 4. Therefore 6 into 1 by 4, then you will get here 2 raised to 3 by 2. 2 raised to 3 by 2 means what? 2 into root 2, and hence a is equals to 2 root 2. Now using second condition, what is the second condition? Sum of second and third number is 6. A upon r plus ar is equals to 6. Now substitute the value of a, that is a 2 root 2. 2 root 2 upon r plus 2 root 2 into r is equals to 6. Next, multiply the whole expression by r. Then you will get here 2 root 2 plus 2 root 2 r into r. Then you will get here 2 root 2 r square is equals to 6r. Okay, and next dividing that whole expression by 2, then you will get here root 2 plus root 2 into r square is equals to 3r. And next, this is the quadratic equation in r, that is root 2 into r square minus 3r plus root 2, that's equals to 0. Okay, and their factors are root 2 into root 2, then you will get 2. Then what are the two numbers whose sum is minus 3 and the product is 2? The numbers are minus 2 and minus 1, and hence the factors here, that is the root 2 into r square minus 2r minus r plus root 2 is equals to 0. Now from these first two terms, take root 2 into r common, then in bracket you will get here r minus root 2, and from these two terms take minus 1 as a common, then in bracket you will get here r minus root 2, that's equals to 0. Again, from these two terms take r minus root 2 as a common, and in the next bracket root 2 into r minus 1, and that's equals to 0. Okay, therefore r is equals to root 2 or r is equals to 1 upon root 2. Okay, we can write also this, that is r minus root 2 in first bracket, in second bracket root 2 r minus 1, that's equals to 0, and after simplification you will get here r is equals to root 2 or r is equals to 1 upon root 2. Okay, now see this. The four terms are a upon r cube, a upon r, ar cube. The value of a is 2 root 2 and r is equals to, if we take r is equals to root 2, then we will get the numbers like this. The first number is a upon r cube, means what? The value of a is 2 root 2, r cube is root 2 bracket cube. Root 2 bracket cube can be written as root 2 into root 2 into root 2, and to the numerator we have 2 root 2. These two get cancelled. That is the product of root 2 into root 2 into root 2. You will get here 2 root 2, and these two get cancelled. Then you will get here a upon r cube, that is equals to 1. It means that the first term is 1. Next, a upon r, that is the 2 root 2 upon root 2. Root 2 get cancelled. The second term is 2. Third term ar, that is a is a 2 root 2, r is a root 2. Root 2 into root 2, you will get here 2. 2 into 2, 4. Therefore, ar is equals to 4. Okay, therefore third term is 4. And the fourth term, ar cube, the a is a 2 root 2, r is a root 2, bracket is to 3. That is a 2 root 2 into root 2 into root 2 into root 2, and their multiplication. Again here, root 2 into root 2, 2, root 2 into root 2, 2. That is a 2 into 2 into 2. Finally, you will get here 8. Therefore, ar cube is equals to 8. Okay, and hence the numbers are 1, 2, 4, 8 are the 4 required numbers in GP if a is equals to 2 root 2 and r is equals to root 2. If a is equals to 2 root 2 and r is equals to 1 by root 2, then the numbers are like this: 8, 4, 2, 1. After simplification, you will get the numbers like this are the 4 required numbers in GP. Okay. Now, next example. If P, Q, R, S are in GP, then show that Q minus R bracket square plus R minus P bracket square plus S minus Q bracket square is equals to P minus S bracket square. Okay. Now solution. Since P, Q, R, S are in GP, therefore Q upon P, here Q upon P is equals to R upon Q is equals to S upon R. Okay, means what? The ratio is a constant. Now see this here. The terms Q upon P is equals to R upon Q. That is Q into Q. You will get here Q square. P into R. Then Q square is equals to PR. Next, R upon Q is equals to S upon R. R into R. You will get here R square is equals to Q into S. And the finally, Q upon P is equals to S upon R. Then you will get here Q into R is equals to P into S. Okay. Now we will expand the LHS. LHS is equals to in bracket Q minus R bracket square plus R minus P bracket square plus Q, S minus Q bracket square. If we expand this, then you will get here Q square minus 2QR plus R square. Expand R minus P bracket square, then you will get here R square minus 2PR plus P square. Expand S minus Q bracket square, then you will get here S square minus 2SQ plus Q square. Now we want to express this in terms of P and S bracket square. Therefore, replace the value of Q, okay, R, okay. Therefore, what is the value of Q square? Q square is a PR. Next, minus 2Q R as it is. R square, the value of R square is a QS. Okay, again R square is a QS. Next, minus 2PR as it is. P square, we required this, and this S square is also we required. Next, minus 2 SQ plus Q square. Q square means what again? PR. Next simplification, you will get here minus 2QR. Here is the first PR. Okay, PR plus PR, that is a 2PR, and minus 2PR. That overall that get cancelled. Next, minus 2QR. Here is a minus 2QR. Next, plus 1SQ, 1SQ, then you will get a 2SQ minus 2SQ, that get again cancelled. Okay, and hence the remaining terms are minus 2QR plus P square plus S square. But what is a QR? QR is nothing but the PS. Replace this QR by PS, then you will get here minus 2PS plus P square plus S square, and this is the perfect square of P minus S bracket square, and that is nothing but RHS, and hence we have proved LHS is equals to RHS. Now, next example. Example number 9. Shraddha deposited rupees 8,000 in a bank, which pays annual interest rate of 8%. She kept it with the bank for 10 years with compound interest. Find the total amount she will receive after 10 years. Here the value of 1.08 bracket is to 10 is equals to 2.1575. Okay, now see this is the solution. The amount deposited in a bank is rupees 8,000 with 8% compound interest. Each year, the ratio of the amount to the principal to that year is a constant. That is the if it were take the rate of interest is 8% and if the principal is 100, then the ratio of amount to the principal, that is a 108 upon 100. कारण की 100 रुपीजचं इंटरेस्ट किती येणार तर 8 रुपीज. मग अमाऊंट किती होणार तर 108 upon the principal. That is this ratio is a constant. Okay, hence we get a geometric successive amount. Okay, we consider the amount at the end of each year for rupees 100. The amount is 108. Okay, and therefore the ratio of amount to principal is equals to 108 upon 100. Okay, for P is equals to 8,000, the amount after 1 year is, that is a 8,000 plus 8,000 into 8 upon 100. Take 8,000 as a common. Then in bracket you will get here 1 plus 8 upon 100. And after simplification you will get here 108 upon 100 into 8,000. Okay. The amount after 2 years is 8,000 into again 108 upon 100 into 108 upon 100. Okay. Then you will get here 8,000 into 108 upon 100 bracket square. This is the after 2 years. After 3 years, then you will get here 8,000 into 108 upon 100 bracket cube. Okay. And in this way, you will get here after 3 years, after 10 years, 8,000 into in bracket 108 upon 100 bracket raised to 10. Okay. And now substitute the value. That is 108 upon 100 is nothing but 1.08 bracket raised to here 10. The what is the value? Its value is at 2.1575, and after simplification you will get here 17,260, and thus Shraddha will get rupees 17,260 after 10 years. And in this way we have completed here all solved examples. Now we'll see the exercise 2.1. Question number 1. Check whether the following sequences are GP. If so, write TN. Okay. Now first example. 2, 6, 18, 54. Solution. T1 is equals to 2. T2 is equals to 6. T3 is equals to 18. T4 is equals to 54. Now here T2 upon T1, you will get here 6 upon 2, that is equals to 3. T3 upon T2, 18 upon 6, again you will get here 3. T4 upon T3, 54 upon 18, you will get here 3. Since the ratio of any two consecutive terms is a constant, the given sequence is a GP. Okay, here A is equals to 2, R is equals to 3, and hence Tn is equals to A into R is 2, n minus 1, the value of A is 2, R is 3, that is a 2 into 3 raised to n minus 1. Okay, this is Tn. Next, 1 minus 5, 25 minus 125. T1 is 1, T2 is minus 5, T3 is 25, T4 is minus 125. T2 upon T1 minus 5 upon 1 minus 5, T3 upon T2 25 upon minus 5 minus 5, T4 upon T3 minus 125 upon 25, that is equals to minus 5. Since the ratio of any two consecutive terms is constant, the given sequence is a GP. Here A is equals to 1, R is equals to minus 5. Therefore, Tn is equals to A into R is to n minus 1. A is 1 into minus 5, or bracket is to n minus 1. This is Tn. Therefore, Tn is equals to minus 5, bracket is to n minus 1. Next, root 5, 1 by root 5, 1 upon 5 root 5, 1 upon 25 into root 5. Here T1 is root 5, T2 is equals to 1 upon root 5, T3 is equals to 1 upon 5 into root 5, and T4 is equals to 1 upon 25 into root 5. Now the ratio T2 upon T1, 1 upon root 5 upon root 5, you will get here 1 by 5. T3 upon T2, 1 upon 5 root 5 upon 1 by root 5, you will get again 1 by 5. T4 upon T3, that is again 1 upon 25 root 5 upon 1 upon 5 root 5, you will get here 1 by 5. The ratio is constant. Okay. Since the ratio of any two consecutive terms is constant, the given sequence is a GP. Here A is equals to root 5, R is equals to 1 by 5, and therefore Tn is equals to A into R is to n minus 1. Substitute the value, that is a root 5 into in bracket 1 by 5 bracket is to n minus 1. This is Tn. Next, 3, 4, 5, 6. Here T1 is equals to 3, T2 is equals to 4, T3 is equals to 5, T4 is equals to 6. We have the ratio T2 upon T1, 4 by 3, T3 upon T2, 5 by 4, T4 upon T3, 6 by 5. The ratio is not constant, that is the T2 upon T1 is not equals to T3 upon T2, is not equals to T4 upon T3. Okay, therefore given sequence is not a geometric progression. Next, 7, 14, 21, 28. Here again, T1 is 7, T2 is 14, T3 is 21, T4 is 28. Now the ratio T2 upon T1, 14 upon 7, that's equals to 2. Next, T3 upon T2, that is equals to 21 upon 14. After simplification, you will get here 3 by 2. T4 upon T3, 28 upon 21. Again, after simplification, you will get here 4 upon 3. Again, the ratio is not constant. That is the T2 upon T1 is not equals to T3 upon T2 is not equals to T4 upon T3. Therefore, the given sequence is not a geometric progression. Okay. Question number 2 for GP. Okay. See this here. If R is equals to 1 by 3, A is equals to 9, then find Tn. We have the formula Tn is equals to A into R is to n minus 1. Here A is equals to 9, R is equals to 1 by 3. Now substitute the value. Then you will get here T7 is equals to 9 into 1 by 3. Bracket is to 7 minus 1. And that's equals to 9 into 1 by 3. Bracket is to 6. Okay. And here 9 means what? 3 raised to 2 into 1 upon 3 raised to 6. And then after simplification, you will get here 1 upon 3 raised to 4. And that is equals to 1 upon 81. Therefore, T7 is equals to 1 upon 81. Next, A is equals to 7 upon 243, R is equals to 3. Then find T6. Again the formula, Tn is equals to A into R is to n minus 1. A is equals to 7 upon 243, R is equals to 3. Substitute the value. Then you will get here, that is a 7 upon 243 means what? 3 raised to 5. Here again, you will get a 3 raised to 6 minus 1 means what? 3 raised to 5. 3 raised to 5, 5 get cancelled. You will get here T6 is equals to 7. Next, R is equals to minus 3 and T6 is equals to 1701. Find A. Now the formula Tn is equals to n into R is to n minus 1. R is equals to minus 3. Okay. Now T6 is equals to A into minus 3 bracket is to 6 minus 1. Okay. Its value is a 1701. Okay. That is A into minus 5 raised to 5. That is equals to 1701. And the fifth power of minus 3 is a minus 243 into A is equals to 1701. Therefore, A is equals to 1701 upon minus 243. Then you will get here A is equals to minus 7. Okay. Now next example, A is equals to 2 by 3. T6 is equals to 162. Find R. Now the formula Tn is equals to A into R is to n minus 1. A is equals to 2 by 3. Therefore, T6 is equals to 2 by 3. In bracket R is to 6 minus 1 is equals to 162. And after simplification, you will get here R is to 6 minus 1 means what? R is to 5. Next, that R is to 5 is equals to 162 into 3 and this divided by 2. Okay, therefore R is to 5 is equals to, after simplification, you will get a 243 and that is nothing but 3 raised to 5. And hence, the value of R that is equals to 3. Okay. Now next question. Which term of the GP 5, 25, 125, 625 is 5 raised to 10? Now here the solution. Let the nth term, that is a Tn, be 5 raised to 10. Tn is equals to 5 raised to 10. Therefore, what is the formula for Tn? A into R raised to n minus 1 is equals to 5 raised to 10. Here A is equals to 5, R is equals to also 5. Now substitute the value. A is 5, R is 5 raised to n minus 1 is equals to 5 raised to 10. And after simplification, here 5 raised to 1 into 5 raised to n minus 1, you will get here 5 raised to n is equals to 5 raised to 10. Therefore, here n is equals to 10. Okay. That is a 10th term is a 5 raised to 10. Okay. Hence T10 of the GP is 5 raised to 10. Next, for what values of x the term 4 by 3 x 4 upon 27 are in GP? Okay, 4 by 3 x 4 upon 27 are in GP. Therefore, T2 upon T1 is equals to T3 upon T2. Substitute the value. X upon 4 by 3 is equals to 4 upon 27 upon x. Okay. Now, the cross multiplication, you will get here x square is equals to 4 upon 27 into 4 by 3. And that's equals to 4 into 4, 16. 27 into 3, you will get here 81. X square is equals to 16 upon 81. Therefore, x is equals to plus or minus 4 by 9. Okay. Now next, if for a sequence Tn 5 raised to n minus 3 upon 2 raised to n minus 3, show that the sequence is a GP. Find its first term and the common ratio. Now here Tn is equals to 5 raised to n minus 3 upon 2 raised to n minus 3, that is a 5 by 2 whole bracket is to n minus 3. Tn plus 1, replace n by n plus 1. Then you will get here 5 by 2 bracket is to n minus 2. Now their ratio Tn plus 1 upon Tn, that is a 5 by 2 bracket is to n minus 2 upon 5 by 2 bracket is to n minus 3. And after simplification, that is a 5 by 2 bracket is to n minus 2 minus, by using the law of indices, n minus sign middle and then plus 3. Then you will get here 5 by 2. Okay, which is the constant. The ratio is a constant. Therefore, the sequence is a GP whose common ratio is a 5 by 2. Now, Tn is equals to 5 by 2 raised to n minus 3. The first term T1 is equals to 5 by 2 bracket is to 1 minus 3, that is 5 by 2, bracket is to minus 2, and after taking the reciprocal, means what? If we change this 5 by 2 by 2 by 5, then the power of this will become plus. Then you will get here 2 by 5 bracket is to 2 means what? 4 upon 25. And hence the first term is 4 upon 25, and the common ratio R is equals to 5 by 2. Now next, find three numbers in GP such that their sum is 21 and sum of their squares is 189. Let the three numbers in GP be A upon R, A, AR. Then their sum A upon R plus A plus AR is equals to 21. That is, take A as a common. Then in bracket you will get here 1 upon R plus 1 plus R bracket complete is equals to 21. And sum of their squares. Okay. That is a square upon R square plus A square R square is equals to 189. If we take A square as a common, then in bracket you will get here 1 upon R square plus 1 plus R square bracket complete is equals to 189. Okay. On squaring expression 1, we get here, that is a square. इथे किती होणार? याचा स्क्वेअर करणार. A square in bracket 1 upon R square plus 1 square means what? 1, and the R square. These are the first square terms. Next, 2 into 1 upon R into 1. Then you will get here 2 upon R. 2 into, that is the first into second, second into third, and the last, first into last. That is the next 1 upon R, 2 into 1 upon R into R. Then you will get here 2. And the last 2 into 1 into R. Then you will get here 2R. The expansion, that is A plus B plus C bracket square means what? A square plus B square plus C square plus 2 into A into B plus 2 into A into C plus 2 into 1 into R. Then you will get here 2R. The square of 21 is a 441. Okay. Now next, split up this bracket into two brackets, that is A square 1 upon R square plus 1 plus R square bracket complete. Next, 2 upon R, 2 and 2R. Okay. From these all the term take 2 as a common, and the next multiplication, here is A square. मग तो A यातला या प्रत्येक टर्मला मल्टिप्लिकेशनला जाऊ द्यायचा आणि या सर्वातनं 2 कॉमन काढायचा. Then you will get here this remaining one A into 2, and then in bracket A upon R plus A plus AR, that is equals to 441. Okay. Next, the value of A square in bracket 1 upon R square plus 1 plus R square, its value is 189. Next, 2A, again the value of A upon R plus A plus AR, that is equals to 21, is equals to 441. Okay. This is the from 1 and 2. Hey, expression number 2 है 42A is equals to 441 minus 189. Their subtraction is a 252. And next, therefore A is equals to 252 upon 42. Then you will get here A is equals to 6. Okay. Now next, A is equals to 6. Now here substitute the value of A here. That is a, if we substitute A is equals to 6, then the next will be 1 by R plus 1 plus R. If we take this 6 to the right hand side, then it will divide 21 to the 21. Therefore 21 upon 6 is 7 by 2. And the simplification of 1 upon R plus 1 plus R is a 1 plus R square upon R, and that is equals to 7 by 2. Next, cross multiplication, that is a 2 into in bracket 1 plus R square. Then you will get here 2 plus 2R square, and the cross multiplication is next, that's equals to 7R. Okay. You will get here quadratic equation 2R square minus 5R plus 2 is equals to 0. The factors are 2 into 2, that is a 4. Therefore, the factors are minus 4r minus r. Now, therefore, take the 2r as a common. Then in bracket, you will get here r minus 2. From here, take minus 1 as a common. Okay. From this, take r minus 2 as a common. Then the remaining terms are in the next bracket. 2r minus 1 is equals to 0. Therefore, r minus 2 is equals to 0, or 2r minus 1 is equals to 0. And hence, you will get the value of r is equals to 2, or r is equals to 1 upon 2. Taking r is equals to 2. Okay. A upon r. The value of a is 6. That is 6 upon 2 is equals to 3. AR 6 into 2. The value of a is 6. R is 2. Then you will get here 12. Therefore, the three numbers are 3, 6 and 12. Okay. Taking r is equals to 1 upon 2. Then a upon r. That is 6 upon 1 upon 2. Then you will get here 12. And the next AR, that is a 6 into 1 upon 2. Then you will get here 3. Therefore, the three numbers are 12, 6 and 3. Okay. Hence, the required numbers in GP are 3, 6, 12 or 12, 6, 3. Now, question number 7. Find 4 numbers in GP such that sum of middle two terms is 10 by 3 and their product is 1. Let the 4 numbers in GP be a upon r cube, a upon r, ar raised to 3. Since their product is 1, that is a upon r cube into a upon r into ar cube is equals to 1. R cube into r, that is r raised to 4, and here again to the numerator r into r cube, r raised to 4, r raised to 4, r raised to 4 get cancelled. A into a into a into a, that is r a raised to 4 is equals to 1. Therefore, a is equals to 1, taking the fourth root. Also, the sum of middle two terms is 10 by 3. The middle terms are a upon r plus ar is equals to 10 by 3. Take a as common. Then in bracket you will get here 1 upon r plus r. That's equals to 10 upon 3. Okay. Substitute the value of a as 1. Then you will get here 1 upon r plus r is equals to 10 by 3. After simplification, you will get here 1 plus r square upon r is equals to 10 by 3. Next, after cross multiplication, that is 3 into 1 plus r square, you will get here 3 plus 3r square. Next, r into 10, you will get here 10r. This is the quadratic equation. 3r square minus 10r plus 3 is equals to 0. The product is 9r square and minus 10r. Therefore, the factors are minus 9r minus r. Then you will get the factors in first bracket r minus 3 and in second bracket 3r minus 1, that's equals to 0. Therefore, here r is equals to 3 or r is equals to 1 by 3. Next, taking a is equals to 1, r is equals to 3. Then you will get here a upon r cube is equals to 1 upon 27 and a upon r is equals to a is 1, r is 3, ar. Okay, that is a is 1, r is 3. Ar cube, a is 1, r is 3. That is 3 raised to 3, that is equals to 27. And the four numbers are 1 upon 27, 1 by 3, 3 and 27. These are the four numbers. Taking r is equals to 1 by 3, a upon r cube is equals to 1 upon, in bracket 1 upon 27, that is equals to 27. A upon r is equals to 1 upon 3, that is equals to 3. AR is equals to 1 by 3. AR cube is equals to 1 upon 27. And the four numbers are 27, 3, 1 by 3, 1 upon 27. Okay. And hence the required numbers in GP are 1 upon 27, 1 by 3, 3, 27 or 27, 3, 1 by 3, 1 upon 27. Now next question. Find 5 numbers in GP such that their product is 1000 24 and fifth term is square of third term. Okay. Now solution. Let the five numbers in GP be a upon r square, a upon r, a r square. Since their product is 1024, that is a upon r square into a upon r into a r square, that is equals to 1024. Okay, and after simplification, r square into r cube, that r cube get cancelled, a into a into a into a, that is a raised to 5 is equals to 1024 means what? 4 is to 5, and hence you will get here a is equals to 4. Also, the fifth term is a square of third term. Okay, fifth term is a square of the third term. Means what? AR square is equals to A square. The third term is A. Its a square is A. After simplification, you will get here R square is equals to A. Now substitute the value. That is R square is equals to 4. Therefore, r square is equals to 4. Taking the square root, then you will get here r is equals to plus or minus 2. Okay. Taking r is equals to 2, a is equals to 4. Then the terms are, okay. First, a upon r square. A is 4, r is 2. That is a 2 raised to 2 means what? 4. A upon r square is 1. A upon r means what? 4 upon 2. That is equals to 2. AR. A is 4, r is 2. That is equals to 8. AR square. That is a is a 4, r is 2, it's a bracket square. 4 into 4, 16. And the five numbers are 1, 2, 4, 8, 16. These are the five numbers. Okay. Taking r is equals to minus 2. Then the numbers are a upon r square means what? 4 upon minus 2 bracket square is equals to 1. Next is a upon r, that is a 4 upon minus 2, that is equals to minus 2. Next, AR, that is a 4 into minus 2, then you will get here minus 8. Next, AR square, that is a 4 into minus 2 bracket square is equals to 16. Therefore, the five numbers are 1, minus 2, 4, minus 8 and 16. Okay. And hence, the required numbers in GP are 1, 2, 4, 8, 16 or 1, minus 2, 4, minus 8, 16. Next question. The fifth term of a GP is X, eighth term of a GP is Y, and 11th term of a GP is Z. Verify whether Y square is equals to XZ. Now here the solution. Let A be the first term, R be the common ratio of the GP. Then T5 is equals to X, T8 is equals to Y, T11 is equals to Z. Using Tn is equals to A into R is to N minus 1, we get, what about the fifth term? That is A into R is to 5 minus 1 is equals to X. Next, this is the fifth term. Eighth term, that is A into R is to 8 minus 1 is equals to Y. Okay. And the 11th term, A into R is to 11 minus 1 is equals to Z. Therefore, next, A into R is to 4 is equals to X, A into R is to 7 is equals to Y, A into R is to 10 is equals to Z. Okay. Next, Y square is equals to, what about the Y? A into R is to 7, bracket square is equals to A square R is to 14. Okay. Now split up this like this, A into R is to 4 in first bracket and the next bracket A into R is to 10. But what about this A into R is to 4? This is nothing but X and this is Z. Therefore, Y square is equals to XZ and hence it is proved. Now next, if PQRS are in GP, show that P plus Q, Q plus R plus S are also in GP. Now the solution, let R be the common ratio of GP, the GP. Next, that is the Q upon R. is equals to capital R. Therefore, Q is equals to P into R. What about the next? R upon Q. R upon Q is equals to again capital R. And if we substitute the value of Q, then you will get here R is equals to P into R square. And what about the S? S is equals to again the same thing. S upon R is equals to again capital R. Then just substitute the value of R. Then you will get here S is equals to PR cube. In order to show that P plus Q, Q plus R plus S are in GP, we have to show that. Okay. Q plus R upon P plus Q is equals to R plus S upon Q plus R. Okay. Next, substitute the values. Here again see this. Q upon P is equals to capital R, and hence we have the value Q is equals to capital R into P. And similarly here R upon Q is equals to capital R. Therefore R is equals to Q into capital R. Then substitute the value of Q, which is the PR, and therefore the value of R is nothing but PR square. Similarly S is equals to PR cube. Now substitute here the values of Q, R and S. See this here, Q plus R upon P plus Q. If we substitute the value of Q as a PR and R is a PR square, and to the denominator P as it is plus Q, and the value of Q is a PR. Take PR as a common, then in bracket you will get here 1 plus R upon P into in bracket 1 plus R. Here 1 plus R get cancelled, PP get cancelled, and hence the ratio is a capital R. Means what? The ratio of Q plus R upon P plus Q is a capital R. What about the next ratio? R plus S upon P plus Q. Again this ratio must be constant, that is equals to R. The value of R. What is the value of R? PR square. Value of S is a PR cube. Again the value of Q is a PR and the value of R is a PR square. Now from the numerator take PR square as a common, then in bracket you will get here 1 plus R, and from the denominator take PR as a common, then in bracket you will get here 1 plus R. 1 plus R get cancelled, PP get cancelled, R square upon R, that is you will get here capital R. Means what? The ratio is a constant, and hence we will say that P plus Q, Q plus R plus R plus S is also in GP. Since PQR is in PQR, S are in GP. Okay. Now, therefore, this is the answer. Next, the number of bacteria in culture doubles every hour. If there are 50 bacteria originally in a culture, how many bacteria will be there at the end of 5th hour? Okay. Since the number of bacteria in culture doubles every hour, there were 50 bacteria originally. The number of bacteria every hour form a GP with A is equals to 50 and R is equals to 2, because every hour that get doubles. To find the number of bacteria at the end of 5th hour, we have to find T6. Therefore, the number of bacteria at the end of 5th hour, okay, that is a T6 is equals to A into R raised to 6 minus 1. Substitute the value. A is a 50, R is 2, 6 minus 1 means what? 5, that is a 2 raised to 5. 2 raised to 5 is 32. 50 into 32, then you will get here 1600. Okay. A ball is dropped from a height of 80 feet. The ball is such that it rebounds 3/4 of the height it has fallen. How high does the ball rebound on sixth bounce? How high does the ball rebound on nth bounce? Okay, now here the solution. The height in successive bounce form a GP with R is equals to 3 by 4. Since the ball is dropped from a height of 80 feet, therefore height at the first bounce is given by A is equals to 80 into 3 by 4. Okay. Height in the sixth bounce is equals to A into R is to 6 minus 1. That is 80 into 3 by 4 into 3 by 5 bracket is to 5. That is equals to 80 into 3 by 4 bracket is to 6 feet. Okay. And height, therefore the height in the nth bounce is equals to A into R is to n minus 1. That is 80 into 3 by 4 into 3 by 4 bracket is to n minus 1. That is equals to 80 into 3 by 4 bracket is to n feet. Okay. That is the height in the nth bounce is equals to 80 into 3 by 4 bracket is to n feet. Okay. Now next problem. The numbers 3, x, x plus 6 are in GP. Find first x, second 20th term, third nth term. Now the solution. The numbers 3, x and x plus 6 are in GP. Therefore, x upon 3 is equals to x plus 6 upon x. After simplification, that is a cross multiplication, x into x, you will get here x square. X plus 6 into 3 means what? 3x. 3 into 6, 18. This is the quadratic equation. That x square minus 3x minus 18 is equals to 0. Their factors are in first bracket x minus 6 into x plus 3 is equals to 0. Therefore, x minus 6 is equals to 0 or x plus 6, x plus 3 is equals to 0. Therefore, x is equals to 6 or x is equals to minus 3. Okay. Now next, when x is equals to 6, the 20th term is given by T20 is equals to A into R is to 20 minus 1, where A is equals to 3, R is equals to x upon 3, means what? 6 upon 3, that's equals to 2. Therefore, T20 is equals to 3 into 2 raised to 19. When x is equals to minus 3, 20th term is given by T20 is equals to A into R is to 20 minus 1. Okay, that is A is equals to, where A is equals to 3, R is equals to x upon 3 minus 3 upon 3, that is R is equals to minus 1. Therefore, T20 is equals to 3 into in bracket minus 1 raised to 19, that is a minus 1 into 3, and therefore T20 is equals to minus 3. Okay. Hence, the 20th term is equals to 3 into 2 raised to 19 or minus 3. Okay. Now the last sub question, that is a nth term. Okay. Solution. When x is equals to 6, nth term is given by Tn is equals to A into R raised to n minus 1. A is equals to 3. R is equals to x by 3. That is a 6 upon 3 is equals to 2. Therefore, Tn is equals to 3 into 2 raised to n minus 1. When x is equals to minus 3, the nth term is given by Tn is equals to A into R raised to n minus 1, where A is equals to 3, R is equals to x upon 3, that is a minus 3 upon 3, R is equals to minus 1, and therefore Tn is equals to 3 into in bracket minus 1 raised to n minus 1. This is the Tn. Okay. Hence the nth term is equals to 3 into in bracket 2 raised to n minus 1 or 3 into in bracket minus 1 raised to n minus 1. Now next question. Mosquitoes are growing at a rate of 10% a year. If there were 200 mosquitoes in the beginning, write down the number of mosquitoes after 3 years, 10 years and n years. Okay. Since the mosquitoes are growing at the rate of 10% and there were 200 mosquitoes in the beginning, the number of mosquitoes in the successive years form a GP with A is equals to 200 and R is equals to 1 plus, that is a 10 upon 100 means what? 11 upon 10. 1 plus 10 upon 100, that is nothing but the 11 upon 10. Number of mosquitoes after 3 years, that is a T4 is equals to A into R is to 4 minus 1. Substitute the value of A is a 200, R is a 11 upon 10 bracket is to 3. Okay, that is nothing but 1.1 bracket is to 3 into 200. Number of mosquitoes after 10 years, that is a T11 is equals to A into R is to 11 minus 1. Okay, that is equals to 200. The value of A and the value of R is a 11 upon 10 bracket is to 10. That is equals to 200 in bracket 1.1 bracket is to 10. And the next, after n years, the number of mosquitoes after n years, that is equals to Tn plus 1 is equals to A into R is to n plus 1 minus 1, that is equals to 200 into in bracket 11 upon 10 bracket is to n is equals to 200 into in bracket 1.1 bracket is to n. Okay. Now the next question. The numbers x minus 6, 2x and x square are in GP. Find first x, first term and n term. Now the solution. The numbers x minus 6, 2x and x square are in GP. Therefore, 2x upon x minus 6 and x square upon 2x. Okay, because their ratio is constant. Then after simplification, that is a cross multiplication, 2x into 2x, you will get here 4x square. X square into in bracket x minus 6. You will get here x square get cancelled on both sides. Then you will get here 4 is equals to x minus 6. Therefore, x is equals to 4 plus 6. Therefore, x is equals to 10. Next, first term. This is the first term x minus 6. That is a x minus 6. Substitute the value of x. That is a 10 minus 6 is equals to 4. This is the first term. Next, nth term. Nth term is a into r is to n minus 1, where a is equals to 4, which is the first term. Next, r means what? The ratio, that is x square upon 2x. X square upon 2x. The value of x is 10. 10 square means what? 100. 2 into x, that is a 2 into 10. You will get here 20. 100 upon 20, r is equals to 5. And therefore, the nth term is equals to a into r is to n minus 1. A is 4. Value of r is 5. That is 4 into 5 is to n minus 1. Therefore, this is the nth term. Okay. Now, in this way, we have completed exercise 2.1. Now, we will see in the next video. Till then, goodbye.